Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Good day, students. Welcome to the last period of physics for this week for our e-learning class. And before we begin business, my name is Oladimeji T.A., the physics teacher of S2PHYWK3P3 Model College, Ibadan. In the last period, we started looking at rectilinear propagation of light, and we discussed some effects of rectilinear propagation of light. Rectilinear propagation of light was defined as the fact that light travels along a straight line, and based on that fact, there are some effects. We mentioned the effect as the formation of shadows, formation of eclipses, and the principle of action of pinhole camera. The first two are natural effects, while the last one is a man-made effect. And in the last period, we were able to look at the formation of shadows. Today, we want to proceed by considering the effects of rectilinear propagation of light. And today, we will look at formation of eclipses. What is an eclipse? An eclipse occurs when a planetary body prevents light rays from the sun from reaching another planetary body. That is, when a planetary body, when we say a planetary body, it may be a planet, a star, or the moon. When it prevents light rays from the sun from reaching another planetary body. Basically, there are two types of eclipse. We have solar eclipse and lunar eclipse. Solar eclipse is also known as eclipse of the sun, while lunar eclipse is called eclipse of the moon. So let's look at them one by one. Solar eclipse. This is also known as the eclipse of the sun, and it occurs when the moon is in between the sun and the earth, so that light rays from the sun are prevented from reaching some part of the earth. Before I show you the diagram, we all know that all the planets move around the sun, and the earth has one satellite, which is the moon, and the moon moves around the earth. So there will be a point that the moon, the sun, and the earth will be on a straight line. Shows that the moon will now come in between the sun and the earth. The sun is stationary, it does not move. So when this occurs, the moon will now block some rays coming from the sun from reaching some part of the earth. You know, the earth is bigger than the moon, so the moon cannot block all the rays from reaching the earth. So only some part of the rays will be blocked from reaching some part of the earth. So when this occurs, we have solar eclipse, as shown in this diagram. Look at the sun, then look at the moon as tiny as it is very close to the earth. Then rays of light coming from the sun. Some of these rays are blocked by the moon, and some part of the earth cannot see the rays, while some will see the rays. As shown from the diagram, the areas that we experience the eclipse can be divided into two. Some we see the total darkness, and they are said to be experiencing total eclipse, while some parts we see partial darkness, and they are said to be experiencing partial eclipse. So as shown from the diagram, places on the earth surface that are in the umbra of the moon's shadow experience a total darkness, and they are in total eclipse. while places in the penumbra of the moon shadow we experience partial darkness, and they are said to experience partial eclipse. Then there is another type of solar eclipse called annular eclipse. And how does that occur? When the moon is far from the earth, the rays coming from the sun intersect before reaching the earth after they have passed through the moon. And therefore, moon shadow, the umbra, may not get to the earth. This situation is known as annular eclipse. So places in the umbra of the moon shadow see darkness with a ring of light, as shown in this diagram. Yes, you can see that rays of light, after they've passed through the moon and the moon has blocked some of it, then before getting to the earth again, the rays intersect. And people on some part of the earth, like part A, which is in the umbra of the moon shadow, we now see a ring-like darkness which appear like a ring of sun, and that is what we call annular eclipse of the sun. Then let's move to the second type of eclipse, which is lunar eclipse, which is eclipse of the moon. This occurs when the earth comes in between the sun and the moon, shows that the light from the sun is prevented from reaching the moon. Remember, I told you that the sun is stationary while the moon moves around the earth and the earth moves around the sun. There may be a point in time that the earth will now come in between the moon and the sun, as shown in this diagram. And as you can see, the earth is bigger than the moon. So the rays of light coming from the sun will be totally blocked by the earth from reaching the moon, so that the moon will now be in umbra of the earth's shadow, and there will be complete darkness, total eclipse on the moon surface, as shown in the diagram. So as shown below, the earth's shadow covers moon completely for about 2 hours because the earth is bigger than the moon. Lunar eclipse occur more often than the solar eclipse. That is, the earth experiences lunar eclipse more often than the solar eclipse. Let me summarize what we have discussed so far. Another effect of retinal propagation of light is the formation of eclipse. And an eclipse occurs when a planetary body prevents light rays from the sun from reaching another planetary body. And we said there are basically 2 types of eclipse: solar eclipse, which is also known as eclipse of the sun, and lunar eclipse, which is also known as eclipse of the moon. And this solar eclipse can be normal solar eclipse and lunar solar eclipse. So normal solar eclipse occurs when the moon is in between the sun and the earth. Shows that light rays from the sun are blocked by the moon from reaching some part of the earth. And because the moon is smaller than the earth, so on earth's surface, some places will be in the umbra of the moon shadow, while some will be in the penumbra of the moon's shadow. So the place that is in umbra of the moon shadow experience total eclipse, while the places in the penumbra of the moon shadow will experience partial eclipse. Then we have another eclipse when, after passing through the moon, light rays from the sun intersect before reaching the earth's surface, so that the place in the umbra of the moon shadow will now see a kind of darkness in form of a ring of light. And when this occurs, we have annular eclipse of the sun. Then the second major type of eclipse is the lunar eclipse, which is the eclipse of the moon. And this occurs when the earth comes in between the sun and the moon. Shows that rays of light from the sun are completely blocked by the earth from reaching the moon, so that the moon will now be in earth's shadow. Because the earth is bigger than the moon, so the umbra of the earth's shadow will now cover the moon completely, so that there will be total eclipse on the moon, and it will only last for about 2 hours. And lunar eclipse occurs more frequently, more often than the solar eclipse. And the next effect of retinal propagation of light we will consider is the pinhole camera. The pinhole camera consists of a light-proof box with a pin-sized hole in the center of its front side. A screen made of translucent paper photographic film is placed at the back of the camera. The inside of the camera is painted black to reduce the internal reflection of light, which can cause multiple image formation. Look at the diagram. The pinhole camera is a man-made equipment. It is a light-proof box with inside painted black. There is a pin-sized hole in front of the camera, and there is a screen or photographic plate placed at the back of the camera. Then when an object stands in front of the camera, the image of the object is formed on the screen, but the image is going to be inverted, that is upside down. Then this is the principle of action of a pinhole camera. You can see that the ray coming from the head of the object goes to the button on the screen, while the one coming from the button of the object goes to the top on the screen. So when the image comes out, it is upside down, and this is not a problem. When the screen is taken out, you just turn it upside down to have an erect image. So the distance from the object to the pinhole is known as the object distance. Distance CP is denoted with object distance, which is denoted with letter U, while the image distance is the distance between the pinhole to the screen. From the diagram, it is PD, and it is denoted with letter V. Then the height of the object is denoted with HO, and it is given by AB in the diagram. Then the height of the image is A prime, B prime, which is denoted with letter HI as shown. CP is object distance from the pinhole, PD is image distance from the pinhole, AB is object height, while A prime, B prime is object height. Then the magnification of the image in the pinhole camera is given by image distance over object distance, or image height over object height, which is given by the formula M is equal to V over U, or HI over HO. Now let's look at the following example to see how the formula can be applied in solving questions. Example 1. A man of 1.85 meter tall stands 5.3 meter from the hole of a pinhole camera of length 25 centimeter. Find A, the magnification, B, size of the image form. Solution from the question. Object height HO is 1.85 meter because the man here is the object and the height of the man is 1.85 meter. Object distance U from the pinhole is 5.35 meter. Image distance is 25 centimeter. When this is converted to meter, we have 4.25 meter because all the distance must be in the same unit. Then magnification is given by image distance over object distance, which is given by 0.25 over 5.35, and this is 0.0467. Then also using the formula that magnification is height of image over height of object. Since magnification has been found, then we equate this to height of image over height of object, and that will give us hi over 1.85. Making hi the subject of the formula, we have the height of the image to be 0.086 meter. If this is going to be given in centimeter, it's going to be 8.6 centimeter. Then let's look at example 2. The distance between the pinhole camera and the screen of a camera is 12.5 centimeter, and the photographic plate is 20 centimeter long. At what minimum distance from the pinhole must a 1.8 meter tall man stand if a full-length photograph is required? Solution. From the question, image distance is 12.5 centimeter. Image height is 20 centimeter because they want the image to completely fill the photographic plate, and the full length of the plate is 20 centimeters. So our image must occupy the whole length. So the image height is going to be 20 centimeters. Then object distance U is unknown. Then object height is 1.8 meter. Since other distances are given in centimeters, so 1.8 meter to centimeter will give me 180 centimeter. Then using the formula, magnification is equal to image distance over object distance, which is also image height over object height. So using this relation, we have that V over U is equal to hi over h0, where U is the unknown. Making it the subject of the formula and solve for it, we have U to be 112.5 centimeter. Therefore, the man must be 112.5 centimeter from the whole of the camera to have his image, which is going to be full length of the photographic plate. Example 3. A room 10.5 meter wide has its window acting as a pinhole to catch the image of a tree outside the room on the wall opposite the window. If the image is 4.5 meter high and the tree is 30.5 meter from the window, what is the height of the tree? Solution. From the question, our image distance is 10.5 meter. Our image height is 4.5 meter. Our object distance is 30.5 meter. Then object height is what we are looking for, unknown. Then from the formula for magnification, image distance over object distance is equal to image height over object height. Using this relation, making h0 the subject of the formula, we have our h0 to be 13.07 meter. That is, the height of the object is 13.07 meter. And this is where we are going to end the discussion on light waves, the topic for this week. Until next week, when I will come your way again, don't forget to go to your assignment portal to look for the questions that will be uploaded, and make sure you find solutions or you answer the questions, and make sure you upload your solutions on the portal on or before the deadline that will be also given as the assignment is given. Until next time when I will come your way again, which is going to be next week. Assalamu alaikum wa rahmatullahi wa barakatuh.